Today on CXOTalk, we're exploring the interesting, fascinating world of AI failures. What is an AI failure? How do we recognize it? Most importantly, how do we avoid these things? Our guests are Iavor Bojinov. He is an assistant professor at Harvard Business School. And my guest co-host, welcoming him back, is QuHarrison Terry, who is the head of growth marketing with the Mark Cuban Companies. Iavor, just briefly tell us about your work at HBS.
My work at HBS is around this new field that's emerging on data science and AI operations. And what the field is studying is how companies should integrate and deploy AI and data science into their operations. So that, in a nutshell, is what all of my research has been about in the past 3 or 4 years since I joined HBS.
And QuHarrison Terry, welcome back to CXOTalk. It's always awesome when you are co-host with me.
This is a special topic that's near and dear to myself because every day I find myself thinking about the future and the impact it's going to have on our lives. Where is all this stuff going? So it's going to be a great show. You know, me, you, and Yav, and we get to talk about AI.
Yav, you're researching AI operations. When we talk about an AI failure, what exactly do we mean?
Definition of AI failure is when AI fails to deliver on the promise. Now, if we want to get a little bit deeper into this, I think it's important to make a distinction between the different AI applications. And at a high level, there's basically two different types of AI. You have internal applications and you have external applications. Now, external applications, those are the algorithms that companies deploy that their customers see. So think like, the Netflix recommendation algorithm, ChatGPT is a great example, the Lyft matching algorithm, right? So these are algorithms that companies deploy to their customers as usually a part of a particular product or just on their own, right? ChatGPT is just a deployment on its own. Internal-facing AI projects, those are usually called data science, and they're really for the employees, and they're designed to improve the operations of the organization. So, for example, this could be some automation in a factory, it could be some recommendation system to help your sales associates prioritize different leads, etc. And when you look at failure within these two different contexts, they look quite different. So if you're looking at internal applications of AI, then the failure is around failing to achieve operational efficiencies or gains. And if you're looking at sort of external applications of AI, the failure is around failing to deliver on sort of revenue growth or cost cutting. So that's sort of the big distinction that I think is really important. And I'm sure we'll touch more on as we continue this conversation.
How do you see AI projects differing than just the general technology projects that an organization is going to take on?
I think the big difference is that AI is probabilistic in nature. And that means that it's wrong. Whereas traditional technology or IT applications, they always give you the same output. So, of course, AI has all of the challenges that come together and come from IT applications, but they have this additional threshold of if you ask the same question twice, you could get two different answers. And very often, those answers could actually be wrong. Right? So that sort of adds an extra layer of complexity that you have to deal with, and that requires a lot more education because it's one thing to say, use this software and always use this software. It's another thing to say, use the software when it gives you the right recommendations, but overrule it when it's wrong, right? That requires a lot more judgment and a lot more education and understanding. So there's lots of overlap, but there are some really interesting, unique aspects when it comes to AI.
With traditional IT projects, we can say that they were mechanistic. We had a body of software and hardware that we needed to implement. We had a defined set of data, employee records or whatever it might be. And we had to get the software installed, get the data running, and roll it out to our employees. And the results were known, were very clear. So failure looked like not meeting expectations, or maybe the project was over time or over budget. AI is very different because the results are so open-ended. So you have the project aspect, but then you have this black box algorithm and data. So what about that? How do these pieces overlay?
And there's one additional thing, which is algorithms change over time. So even if you get your project, your AI project done on time, you deploy it, you scale it, people are using it, 6 months down the line, the predictive accuracy that you had could have plummeted by half. Or maybe some new biases could have been introduced. So basically, you have all of the potential IT failures with a whole layer of complexity around the development of it, the evaluation of it, the deployment of it, and even the management and sort of monitoring in the future. And I think when it comes to AI failure, and we'll talk a little bit more about this, I'm sure, in a minute, I think there's sort of different areas where it fails. And it's really important to understand what an AI project actually looks like. So then you can try to identify each of the failures within those steps of that project.
You call it the probabilistic failures of AI. It's an interesting way to bucket it. So you almost think about AI projects as something that a company endeavors in. You just almost start off and say, "Hey, we're going to fail." But if we don't fail, the outcomes or the probabilities are going to be drastically different than anything we would get within our organization just by our own pursuits. Is that the way you envision that?
Absolutely. And then the other thing is the bar for AI is much higher than for humans. Think about self-driving cars, right? That's an AI. If a self-driving car gets into an accident, that makes mainstream news, right? So if a self-driving car makes a mistake, that's headlines on the New York Times. If a driver makes a mistake, that doesn't even get mentioned on local news, right? So the threshold that AI has to overcome in order to be sort of widely deployed is just much higher than what humans have to overcome. So that's what I sort of mean. And that's because AI is sometimes wrong. And people are they're not used to the fact that they're using some sort of tool that, 9 out of 10 times will just give you the wrong suggestion. But that's what AI does. Those 9 times, it's really good and it's much better than what you could do on your own. But sometimes it's just categorically wrong. And that sort of changes the nature of how a person interacting with the AI, the level of education that they need to have and the level of understanding that they need to have and the level of autonomy they need to have is very different compared to just a typical software or a typical IT product that just says, okay, every single day, this is what you do. This is completely deterministic. There's no randomness. So that's what I mean by the probabilistic nature. Does that help with the intuition there?
It makes a ton of sense. It's quite fascinating too, because when you think of AI and the bar that's set for it, I almost feel like that's just for the next decade or so. Eventually, we won't make a big deal that AI is running a lot of the operations. And I think back to, when I was in grade school, it was a big deal to use spell check, right? Like you didn't want to use a variant of Microsoft Word that didn't include spell check. And when you did use that variant, you knew the differences. You were like, man, like I might have grammar issues or I might spell that word incorrectly. And now today, spell check is like ubiquitous across all of our devices. It's not software specific. It's not even platform specific. If you use iOS, Android, Windows, you're going to get some variant of autocorrect. And the bar isn't that high. Like you said, we just kind of accept it, even though it's not that good.
Be sure to subscribe to our YouTube channel and hit the subscribe button at the top of our website so we can keep you up to date on the latest upcoming live shows. When I was studying traditional IT failures going back some years now, really the primary causes of failure had to do with less about the technology and more with poor communication among stakeholders, mismanaged expectations among the customer, the software provider, and the services provider, the system integrator. But those are project aspects. With AI, it seems like all of those pieces are in place. But then again, layered on top of it, you have additional levels of complexity. Again, is that a proper way to look at it from your view?
I think it's really helpful to break down an AI project into several distinct areas. And I think within each area, there's opportunity for failure. So let me do that right now, and then we can spend a little bit of time about talking about each of these 5 steps. So the first step is the project selection. So this is when you think about which algorithm or which operation process should we try to digitize and maybe automate with an algorithm. So this is really about, there could be potentially 200-300 different projects you can go after, and this is about picking the right project that is going to be both impactful and feasible. The second step is the actual development of this. This is when you take your idea, you get the data and you build that prototype to check if it's going to work as you expected. The third step is the actual evaluation of this. So this is when you've built your algorithm, you've tested it sort of on historical data, and now you're going to deploy it on real people and see if it's having the type of impact you hope that it would have. Now here, a lot of companies, they fail to do this step very carefully, and they should be actually way more careful about it because there's studies coming out of places like Google and Microsoft that say something like 70 to 80% of everything the company tries has a negative or neutral impact on the very same business metrics they were designed to improve. So chances are whatever you've developed doesn't really have that much of an impact on your customers or the users. The fourth step is then the actual deployment and the scaling of this to 100%, right? Because usually in your pilot, you're going to start off maybe with one team, one product area, maybe 5% of your customers. But at some point, you need to launch this to absolutely everyone. And then the final step is the actual management of this, which is you continue to monitor it, you watch for biases, you watch for drift, you watch for all the other things that could go wrong over time. So these are the sort of the 5 steps of an AI project. And then within each of those steps, there's lots of ways the project could fail. And I think in some places it's similar to an IT, but in some places of these sort of 5 steps, there's some very unique things about AI failure.
Let's jump for a moment to Twitter because I love taking questions from the audience. You guys in the audience are so smart, so bright, and we have a couple of questions that have come up. So let's jump there and we'll come back and look at what you were just describing. So Chris Peterson says, it sounds like AI today is nothing but machine learning based on neural networks. In the past, industrial AI projects were based on other technologies such as rule-based expert systems, and they created tremendous value. But they didn't have that probabilistic element. Is that just gone now, or is there still a place for these systems?
I think by and large, these systems have gone out of practice because we've shown that with probabilistic AI, we can do much better. There's definitely some areas where these are still deployed. I think it's sort of in manufacturing, there's some rule-based systems, but really we've sort of transitioned to this branch of machine learning. And I love this question, right? Because even a few years ago, I would not call this AI, I would call this machine learning. But over the past 3 or 4 years, there's just been this transition to use the term AI to basically mean not artificial intelligence, not in the way the computer scientists thought about it in the 60s and 50s when that term came into being. It's really about any process that is now being automated and the computer is handling. That's usually referred to as AI these days. And that kind of encompasses machine learning. And that could be through neural networks, or it could be as simple as a regression, right? Simple linear regression for many companies is now AI.
All right, yeah. We've got a question from Twitter that is actually quite good. Arslan Khan is wondering if AI is being constantly updated, the data, the algorithms, etc. This requires a ton of resources. And if you're a small business, you might not have the disposable income to throw at these big projects and you will be at a disadvantage in unlocking the potentials of AI. What should you do in that case? And what's your thoughts on that, Yav?
I think this is a big misconception. You don't need to throw large amounts of resources for the vast majority of machine learning algorithms. Of course, there's a handful of sort of AI algorithms that need lots of data, lots of compute. These are things like image recognition, video ranking, the large language models that we've seen like ChatGPT. They need lots of data, lots of compute. But actually, for most other tasks, you really don't need much. Like you can run everything on your basic laptop with a single core within a few seconds, right? Like modern computers are really, really powerful. So for most of your AI applications that can actually add real value, they're not the ones that are doing image recognitions. They're the ones that are maybe helping you figure out which lead you should pursue, maybe which sales lead, or maybe they're looking at a bunch of your products and identifying which of your products are actually performing really well on Amazon and which of your products are performing really poorly on Amazon. And that sort of gives you information that you need to, go and change those SKUs and maybe change the description, add some more images, etc. To do that, I can do that on a laptop within, not even 5 seconds for that algorithm to run. So I think that's a big misconception that you need lots of resources. You don't.
If you were getting started in implementing AI in your org, what area do you think is best positioned for a small company? Outside of what you just mentioned, like just specifics, if you have something top of mind.
It really depends on company to company. The first thing is to definitely get started, right? You have to pick something. Usually, I would try to focus on anywhere between 2 to 5 pilots. And you want these pilots to have direct implications on revenue. Because if you're going after projects that are not going to impact your revenue, and it could also be cost cutting, right? It doesn't have to just be revenue. It could be going after profits. But if you're not going after those projects that are going to have a big ROI, you're not really going to see the value. So find those 2 or 5 projects that are both feasible, meaning that you have the data, you have the skill, you have the infrastructure to implement this, but are also going to be impactful.
If I'm a leader, I'm in a leadership position, I don't have my team. I'm hearing you tell me, I can possibly implement AI to either make more money or cut costs. This sounds like about the time that you should get started. You should start developing these things, if I'm hearing you correctly.
Absolutely. And here's the thing, you don't have to go at this alone, right? If you're a company that has no expertise in these, there are like hundreds of different companies out there that are offering some AI-based solution. Now, you have to look at those carefully and cautiously because a lot of them are just, trying to sell you snake oil, but there's definitely some out there that can really help you transform. And you can do that without actually having to build a lot of these resources in-house. Now, that's a great way to get started, maybe for 1 or 2 projects. But if you want to transform your organization and really become an AI first firm, you're going to have to hire those people in-house and you're going to have to really transform both your business and your operating model. But to get started, really, you don't need that much. I mean, you could do this. Some of this you could do yourself. There's like a lot of no-code AI solutions where you basically have a sheet that looks like Excel and you put in, all of your sales leads and you say, hey, here are the sales I had in the last quarter. Here are all my leads right now. Can you just rank them for me? And it will just build a model. You don't even need to worry about what model it's building. It will build a few different models and it will say, okay, these are the top ones that you should really call. And then you can use your own judgment to really check, do they agree with my intuition? Do they agree with my sales leads? For that, you don't need an expert. You just sort of need to understand the problem and you need to get the data and find sort of an external solution that you can leverage.
Can we break up AI failures into 2 buckets? Number 1 is the project aspects. The project is on time, it's on budget, it meets the stakeholder goals, whatever the outcome is. And number 2 is the unexpected results arising because it's AI. Can you break it up, and how would you think about it in those two separate ways?
I think the first category is absolutely right, which is around just the project failed to really show value. The second one, as you said, is, it doesn't have sort of the predictive accuracy we were hoping for. We don't even have the data to sort of train the models to the accuracy. We don't have the infrastructure to deploy it. And then there's a third element I think that is important here, which is the human element, which is we built it, it works really well, but the human doesn't want to use it. And I think you see this a little bit in IT with the sort of the change management, but here the usage and adoption is different, right? Because in IT, it's just, do you use this or do you not use this? With AI is, do you use this when the recommendations are correct, and do you not use this when the recommendations are wrong? Right? So there's that additional piece of it. And I think lots of companies will fail here because, they'll try to build an algorithm that is just such a black box that people just don't understand it. They're not involved in the process. So then they just don't know when to use it, when not to use it, what are the risks associated. And that side, I think, is also a big failure that many companies fall into.
Do you really believe that the user experience of how you integrate these AI suggestions or even outcomes, is that going to play a part into a company being successful or inevitably running into a failure at some point?
You can have an amazing user interface, but if you don't integrate it into the operations, it still would fail. So let me give you an example from healthcare. In healthcare, there's so many AI companies that are trying to solve wherever it is. Very often, the people who are involved in those companies are not physicians and they don't understand the typical process flow of a physician. So what they'll do is they'll come to the physician's office and they'll say, okay, here is an iPad with this beautiful UI, and I want you, once you've examined the person, I want you to type up all of these things into this UI. We won't integrate into Epic. We'll just have this beautiful UI. It's been tested by 100 people. Go and use this. But it's not integrated into the actual process flow of that physician, so they're not going to use it, right? So that's, I think, something that people very often forget is the actual process that individuals go through in their work, and you need to make sure that the AI solution fits into it. And then the other thing, and this is cute, what we were talking about a little bit earlier as well, is there is that really, really high bar, and people panic when they see a mistake that's being made by the AI. And there's lots of research on this where people have run these experiments and they'll have, an AI that's able to diagnose cancer at a much higher rate than an individual clinician. But the second that clinician sees an example of the AI being wrong in like a very obvious way, where the clinician looks at it and goes, oh, no, it's really obvious. Like if you look over here, it's clearly, this is cancerous. They immediately shut off and they're like, I don't want to use this. This is wrong. Right? So you have the UI, you have the process integration, and then you have the trust piece, which is very easy to break in these types of AI examples.
And Data Rebel on Twitter comes back and says, to help understand the difference between AI and IT projects, look at the data sets. That seems like a reasonable point.
Yeah, absolutely. I mean, in IT, the data sets were usually very fixed. As Michael, you gave the example of it's your employee data, right? It's a very nice rectangular table that has employee ID, it has how many years you've been in the company, and so on and so forth. With AI, the data sets tend to be much larger, and they don't tend to be structured in the same way, right? We could have text, we could have images, we could have videos, and all of that is sort of being pulled into one area and very often stored in something like a data lake, and it could be completely unstructured. And then yet you still you want to use this for some sort of predictions, right? The cancer example I was giving you, that's not looking at the patient's height and age, that's looking at MRI scans, it's looking at lots of other pieces of information, and it's trying to build a model. So the model is just so much more complicated and integrates a wide variety of non-structured and structured data to make those predictions. So I think that's a really, really good observation.
We have another question from Twitter from Arsalan Khan, and it revolves around this whole concept of AI,
Yes.
a term that we've heard in the business industry for a long time, known as digital transformation. Should we consider the use of AI as a digital transformation trope, or is they entirely different things, in your opinion?
Digital transformation is around taking your operating model and trying to digitize it. So going from analog and having sort of handwritten notes and files to having those be digital in maybe some sort of searchable environment. AI is, I think, sort of the next step after that. So you need to be digital in order to fully leverage AI. But those two things are not necessarily the same, right? You can have a digital operating model without really having AI integrated. And the way I sort of think about it is, if you think of sort of the value curve versus how many customers or whatever, you sort of have some sort of curve. And then what AI does, it sort of adds more value. So it sort of shifts everything up on that value curve. But it is sort of distinct from digital. And I think that's where you're starting to see this term AI first companies also emerging, right? Before it used to be sort of digital first firms. And those were all our typical digital native companies. Think Facebook, Meta, so on and so forth. They were, in the beginning, they were sort of just digital companies. They weren't really using algorithms, but now they're becoming AI first companies where AI is being integrated into everything that they're doing. And I think Microsoft is a beautiful example of a company that has sort of transformed itself multiple times, right? They sort of transformed themselves to become a digital company, and now they're transforming themselves into being an AI first company. And you see it with sort of the recent announcements of ChatGPT being integrated into Bing and into, basically every part of Microsoft. You're starting to see these types of integrations.
We have another interesting comment from Chris Peterson on Twitter, and he's asking about academic programs to help train folks to understand why an AI model has come up with a specific answer.
Yeah.
And so if we put this into the AI failure context, to what extent is this issue, the lack of transparency and the lack of probabilistic or mechanistic results, to what extent is this a category of failure? It doesn't have to be just with prediction. I mean, you can think of many different uses for AI. And again, it moves us a very clear distinction from traditional IT projects where a failure might be, we can't print paychecks.
Over the past couple of years, I've been heavily involved in building out HBS's data science curriculum. And in particular, we've actually developed a course called Data Science for Managers, which starting in the fall is actually going to be part of the required curriculum for all 900 of our MBA students at HBS. So that means along with accounting, marketing, finance, they're going to be learning about data science and they're going to be learning about data science and AI operations. And really, that's sort of exactly at the heart of this question, because we realize you need to educate people and you need to sort of start educating at every level, right? Not just at the executive level, but even at sort of the MBA level. We want to sort of educate them to understand these challenges. Now, where do you see this in the failure points? For me, this really is in the deployment stage, which is when you sort of take your pilot and you want to scale this up. And the way you drive deployment, I have a very simple framework to think about it, which is the E2 adoption framework, which centers on education to increase knowledge, automation to reduce switching costs, and trust to facilitate the adoption. And then trust is further broken down into employee-centric design, adds real value, and transparent. And here, transparent, what I mean by transparent is being clear on what was the data that this algorithm was trained on. Because understanding that will help you understand when you should overrule this algorithm. Let me give you a very concrete example. If it was, again, I'll go to healthcare because I think there's a lot of really simple examples there. Imagine you trained an algorithm on detecting cancer in adults. And the physician knew that, right? They sort of knew it's just for adults. If they ran this algorithm on children, you'd be very skeptical on the results because the physiology of adults and children is fundamentally different, right? There's lots of different hormones, etc. So those things are very different. The denseness of tissue is different, etc. So if you knew and it was really transparent what the training data was, that physician would understand and be able to overrule this. But if they just had an algorithm that just said, oh, use this algorithm to detect cancer, and they had no idea who this algorithm was trained on, they wouldn't really know when to overrule. And here I gave the example of adults and children, but it could be, if you have something that's trained in Europe, it probably doesn't apply directly to Japan or to South Korea, etc. Right? So all of those transparency angles are really important in understanding when you should overrule the algorithms, and I think that's a big failure.
I want to talk about some of the ethical considerations as it relates to AI. There is an ethical and privacy consideration that companies have to talk about. And sometimes when you just release a model or when you open up your data set to a new AI thing and it's unproven, you're going to have some really unintended consequences. How should an organization think about that? And how do you handle that in your research?
Ethical considerations should not be bolt-ons. It should not be something you think about after you've built your algorithm and you deployed it, right? Ethical considerations need to come at the beginning. They need to be at the center of the conversation around even picking, should we go after this project, right? That's actually part of the feasibility, thinking about the privacy, thinking about potential biases, both in the data and sort of the predictions of that. So that's sort of my first observation is a lot of companies they go and they build stuff because they're trying to iterate as quickly as they can. And that's great, right? It's for IT, it was really sensible to try to iterate, break things, move as fast as you can. But with AI, we now face this unprecedented scale where you could take an algorithm and, right, like ChatGPT, that went to 1 million people in several days, right? So the scale is just completely unprecedented that we're seeing with AI. So if you have biases, if you have privacy issues, they just scale and grow so much quicker, which is why you have to think about them at the beginning. Now, for privacy, there's a core set of principles called privacy by design that I would encourage every company to sort of embrace. And there's sort of 7 principles. And I'm not going to go through them now. You can sort of Google that yourself. But, a lot of those principles are around making sure that it's something that you do at the beginning. It's not a bolt-on. It enables full functionality. So that's kind of how I think about privacy. Then when it comes to sort of the bias aspect, this is a really hard question because what happens is AI isn't biased by nature, but it takes biases in the data and it scales them and it grows them. So here you have to think really hard about, is my data biased? And there's actually a group of machine learning experts have been working over the past decade to try to make algorithms as unbiased as possible. And you can sort of have these types of constraints where you require that there's no differences between men and women in terms of predictive accuracy and so on and so forth.
Now we have a comment from Arsalan Khan that's again relating to all of this. And he says, what about the power of veto when using AI for decision making? What happens when execs or others go with their gut rather than with AI recommendations? And to me, this really also connects with this whole idea of responsible AI and training people to understand realistically what's going on with the AI so that they can make informed decisions and have some type of internal radar to get a sense of when bias might be introduced. And if you're developing these systems, especially you need to know to put in mechanisms to avoid the bias. But getting back specifically to his question about executives who go with gut feel, and don't listen to the recommendations of the AI?
I think there are two parts. The first part is, as we've talked about, AI is sometimes wrong. So if there's a very good reason, of course, the executive or even the frontline worker who's using the AI should overrule it. The place where executives get this wrong all the time is really when it comes to sort of the evaluation piece of it, and when it comes to maybe looking at results from something like an experiment, where they really want to use their intuition to overrule those results, but really experiments and A/B testing are a way of collecting data from your customers. And when an executive overrules it, they basically say, I know better than what my customers want. So in those situations, I would really, discourage executives from overruling the data. But when it comes to sort of recommendations where the algorithm could sometimes be wrong, then yeah, of course you have to overrule it when it is. But here's the thing, you have to then actually go back and try to evaluate. Was the algorithm actually wrong? Or was the person wrong, right? Can you try to understand that? Because if you keep overruling the algorithm when the algorithm is right, then you're going to end up getting the wrong answer, and you're not really going to have the benefits of AI.
I work at an enterprise organization, and I am concerned about some of the governance and regulation that's going to be enforced on these companies as it relates to big black box algorithms. How do you think I should best prepare for that? Because that's a big topic, and the more AI we integrate, the more we get addicted to AI, and the more it enables us. Does it open up an entirely new threat or domain for us to just consider as we think about our standards and just our org?
Let's focus on privacy here for a second. Now, if you look at GDPR, one of the core rules in GDPR is that everyone has a right to be forgotten. And that means the company has to delete all of your data. But if you have an algorithm that's trained on someone's data that you're supposed to have deleted, it turns out through sort of modern machine learning practices, we can back that out. So now, what does that mean for algorithms? It means we need to develop new strategies to allow us to go into that data and remove that observation from the model. Now, if you're training these really large, generative models like ChatGPT, turns out removing the data is extremely hard, and you can't really retrain the model because those can take months to train. So there's a whole group of researchers are working on that particular area. And that's just one example of how things are changing. But I want to come back to the governance issue. And again, this is something where it can't be a bolt-on. You can't do this after the fact. Right? Governance has to be in the beginning when you're starting the project, and you really need to bring together sort of three groups of people, right? You need to have security there this was the conversation last week, right? In CXOTalk, right? You need to have security in there. You need to have legal in there, because they want to make sure you're sort of complying with the laws. And then you need to have someone that's an expert in sort of privacy and the ethics of it, so they can raise the right questions. So when it comes to governance, the thing that I've seen be really successful is companies developing these sort of tech governance meetings, where if you want to develop a new advanced algorithm, you go through one of these reviews just to check you're really, above the board on all of these different dimensions. And the idea is you sort of get everyone in the same room, 30 minutes, an hour, you explain what's going on, they give you feedback, and you make sure that you have all of these considerations top of mind at the beginning of the project and not the end.
One of the things that is very clear is the level of complexity. This is this notion of AI failure. It's not crystal clear how to even define it, but we can say that there are many different facets to it. And very quickly, Chris Peterson comes back and he says, from a security perspective, how do we guarantee that the training data isn't poisoned by a bad actor, since the data aspect is so important? So just very quickly, any thoughts about the poisoning of training data?
This is where you really need to have the right security around the data. And what a lot of companies actually do is they have their real data locked in sort of very secure environments where even the data scientists that work there don't interact with it. And what the data scientists work with are sort of synthetic data sets that are generated using methods that are sort of what's known as differentially private to ensure that even what the data scientists within the organization are seeing is not actually the real data, but it's sort of like a privacy protected version of it. So then if you have everything under sort of this really secure lock and key that even your own employees, most of them can't touch, it makes it harder to really poison the water there.
What is your final advice on preventing AI failures?
It comes back to thinking about those 5 different steps that I outlined in the beginning, right? The first one is really careful thinking about the project selection. And here there's a lot of great research that's been done, some of it from my colleague here at HBS, Jackie Lane, that basically shows that people entangle feasibility and impact. So what that means is if you look at a project and you say it's high feasibility, people often say it's high impact, or vice versa. And this is just human nature, and they've done field experiments and they have shown this. So what you have to do is you have to disentangle those things, right? You have to think about impact first and then feasibility. And that will allow you to sort of overcome those initial challenges of, oh, we don't have the right data, we don't have the right time frame, or this is never going to actually be as impactful as we thought. So that's sort of the first bucket of failures that you can overcome. And it's a very simple thing you can do, but it's really, really powerful. The second one is when it comes to the actual development. And here you want to think about AI development as any other production process. You want to think about it as almost like in manufacturing. And 2 of my colleagues, and Michael, you had Karim Lakhani here a few months ago, they have this model called the AI factory, which is around how you can really scale AI and build sort of like a production system around it where you have a data pipeline protected by code with algorithms built on top of it, and then sort of an experimentation platform. So you can do that, and that's really going to standardize things. It's going to improve speed, and it's just going to make everything so much easier internally. The third piece is the evaluation. This is where you really want to use systematic experimentation to make sure that you're really adding value. And here, my big recommendation is be scientific. There's a lot of research that says if you take a scientific approach to product development, you're going to do a better job. And what do I mean by this? It's as simple as saying, if, then, by, because. So if I make this change, then this outcome is going to improve by this much, and here is my evidence. So by taking the scientific approach, you become much better at evaluation. Fourth one is, I already talked about it, is the deployment, is the E2 adoption framework. And then the management is really, you have to make sure that there are algorithms that manage. They're just like employees. They need managers. You can't just build it and leave it in the wild. And that's sort of my final point.
And then lastly, we're going to end on this question. It's from Arsalan Khan on Twitter. Rapid fire, just answer this in 30 seconds or less. Who should we sue when AI is wrong, especially when AI is being used in life or death situations?
The answer is the human. All of these systems are human in the loop. And in healthcare and FDA, etc., it's the human that is the final decision maker. These are decision augmenting tools, not decision replacement tools.
I love that answer. Sue the human, and makes perfect sense. And with that, unfortunately, we're out of time. It's been such a quick conversation. We've been speaking with Iavor Bojinov from Harvard Business School and QuHarrison Terry, who is the head of growth marketing for Mark Cuban Companies. And gentlemen, thank you both. Iavor, thank you so much for being with us.
Thank you.
And Q, it's always a pleasure to see you, and I'm looking forward to doing this again with you as co-host on CXOTalk.
Likewise.
Everybody, thank you for watching. Before you go, be sure to subscribe to our YouTube channel and hit the subscribe button at the top of our website so we can keep you up to date on the latest upcoming live shows. Thanks so much, everybody. I hope you have a great day, and we'll see you again next time.